Now we're going to finish up section 5.4 by doing integrals of exponentials. Well, because the derivative of e to the x is e to the x, that means the integral of e to the x dx is e to the x. So if your exponent is just x, it's very nice and easy. But that very rarely happens. So we also need the integral of e to the u du equals e to the u plus c. So again, all we have is the exponential function e to a single thing. So we may have to do u substitution to make that happen. So let's do a few. All right, number one. The integral of e to the 2x dx. All right, my exponent is not just x, so we're going to have to do u substitution. So just like before, if you have integrals and fractions, you're going to pick the denominator to be u. If you have the integral of an exponential function, you're always going to choose u to be your exponent, which is 2x. So then du dx is 2, and du is 2 dx. So I can rewrite my integral as the integral of e to the u. But again, all I have left is dx. I need to make that match up, and it doesn't currently. So I'm going to make it match up. So I'm going to divide each side by 2. So 1/2 du is dx. So now I can get rid of dx and put in what dx is, which is 1/2 du. So get rid of du and put in, get rid of dx, put in 1/2 du. So now I have something I can integrate very quickly. Leave my 1/2. The integral of e to the u is e to the u plus c. It is still an indefinite integral. I don't have the numbers on it. So I'm just leave my plus c, but don't forget to plug back in for your u. So going back up and looking, my u was 2x. So I'm going to get 1/2 e to the 2x plus c. I'm done. That's what I'm looking for. So you're going to do your u substitution to get it to be e to the u every time. All right, well, they don't always work out as nicely as that one did. So number 10, the integral of e to the sine x, all of that times cosine x dx. All right, this is still an exponential function. I still want to choose u to be my exponent, which is sine x. This works out very nicely because the derivative of sine x is cosine x. So I get du equals cosine x dx. So I get the integral of e to the u, and then what I have left is cosine x dx. That matches up exactly with just du. And the integral of e to the u du is e to the u plus c. We'll plug in what u is, and I get e to the sine x plus c. Done. These are really nice. Don't try and make them harder than they are. All right, let's do another one. So number 11. My numbers might be off. The integral of x squared times e to the negative 2x cubed dx. All right, again, I have an exponential function inside my integral, so I'm going to choose u to be my exponent, negative 2x cubed. So then du dx would be negative 6x squared, and du is negative 6x squared dx. So I get my integral with e to the u. Well, what do I have left? I have left x squared dx. Matches up closely, but not exact. I have to get rid of that negative 6. So I'm going to go ahead and divide each side by negative 6. So I get negative 1/6 du equals x squared dx. All right, so when I get rid of my x squared dx, I'm going to put in negative 1/6 du. So now I can take the integral of quickly. Leave the constant out front. The integral of e to the u du is e to the u plus c. So plug everything back in, and I get negative 1/6 e to the u. Well, u was negative 2x cubed plus c. And we're done. All right, one last problem. The integral of 1 over e to the x dx. All right, well here, my exponential function is not by itself, so I might want to think to do a fraction. The denominator is what I would choose, but the derivative of e to the x is e to the x. I don't have that in the numerator, so that's not going to work. So we have to come up with something else we can do, which is to rewrite it as e to the negative x dx. So bring it up out of the denominator and just make the exponent negative. Then u can be the exponent of negative x. du dx would be negative 1, or du equals negative dx. So I get the integral of e to the u, and then dx becomes negative du. So leave the negative. The integral of e to the u is e to the u plus c. So I would get negative e to the u, which is negative x plus c. Excuse me. Well, I can't leave a negative exponent, so I get negative 1 over e to the x plus c. And we're done. This concludes our section 5.4 and the end of chapter 5.